Let's look at some parts of our similar triangles. So if two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. So we're going to look at three different parts of our triangles and how they relate to if they are similar. So this line here that is perpendicular to the base and goes up to the vertex, these are our altitudes. And if our triangles are similar, then we put the altitude of one, so BD in this example, over the altitude in the other, and that should equal the side of the first one over the corresponding side of the second one.
First Bob. Hello.
This second part of our triangle, it cuts the angle in half on each of our triangles. So these are angle bisectors. And if our triangles are similar, then our angle bisector, QS on the first one over UW on the second one, would be proportional to the side of the first one over the side of the second one. And finally, we have our medians. Remember, our medians go from the vertex down to the base, and they cut the base right in the middle. These are our medians. So if these two triangles are similar, then the median of the first one over the median of the second one is going to be proportional to the side of the first one over the side of the second one. Okay, let's look at a few examples. So these two triangles are similar. So we want to find x. What are we given here? Let's look. Then we've got this line in the middle. Does it cut our angle in half? We don't know, so we don't know if it's an angle bisector. Is it perpendicular with the base, creating a 90-degree angle? It's not, otherwise it would be marked. Is it going from the vertex to the base and cutting the base exactly in half? It is. So it's our median. So these are our medians. So we can put the median of the first one, which is x, over the median of the second one, equal to the side of the first one of the sides. Either side should work. Just make sure that whatever you pick here, I picked the ST. We've got to pick the corresponding side here. So what is corresponding to ST? That's our DE. So we're going to put that over 20. So then again, you're going to do your cross product, solve for x equals 12. If you are getting stuck and not getting 12, you're getting stuck with the math here, let me know individually. I'm not going to go through it every single time. All right, this example, what do we have? We've got our line, our triangles with our lines. Which one? Do we have an altitude, an angle bisector, or a median? Well, it goes from the vertex down to the base, and at the base it creates a 90-degree angle. Well, that's our altitude. So we're going to put the altitude of the first one over the altitude of the second one over the side of the first one. And what's our corresponding side? We've got HI is what we chose, so LK, this one right here, that's our corresponding side, so that's going to go over 14. And we are going to cross multiply, and x is going to equal 17.5. So all we're doing is, for all of these really, is putting the line in the middle over the line in the middle, and then putting corresponding side over corresponding side and solving for x. So this one, what is it? Is it an altitude, angle, bisector, or median? Well, we see that it cuts that angle on each of these right in half, so it's our angle bisector. So I'm going to put angle bisector over angle bisector, side over corresponding side, cross multiply, solve for x equals 28.5. All right, this last example, I'm not going to go through all of it, but I wanted you to see it because sometimes our altitude is not always inside our triangle. Our altitudes can actually be outside of our triangle. So you see how these create our 90 degrees. So if you're seeing something that looks like this and it's creating, this is our altitude. This is the height of our triangle, even though it's not inside. So then we would still put 12 over 15, x over 42. And then, of course, cross multiply, and x ends up being 33.6. All right, one more. Angle bisector theorem. So if an angle bisector in a triangle separates the opposite sides into two segments. So we've got an angle bisector because this is an angle bisector because it cuts the big B angle right in half where these two angles are congruent. It's going to separate, go down to the end and separate this in two sides that are proportional to these sides. So let's look at what that means. We're told that it's an angle bisector, and we need to solve for x. So what I can do is I can take this small side of the base over this side, and that's going to be proportional. So as I was saying, the two sides that it creates, that it cuts into two parts, it's going to be proportional to the two sides. 12 over 18. So again, we're cross product, solving for x equals 7.2. So it's just the same thing, over and over. We're told that this is an angle bisector. So these two sides are proportional to this one. The total length is 39. I can get ML, which is 24. So we've got 15 over 24 is going to equal x over 36. When I cross multiply, that's 22.5. So again, I included this one because it's got some equations instead of just an x. So this is our angle bisector. This is our base that's cut. So 27 over, this is going to be 18, is going to equal 3x minus 9 over x plus 11. So when I do my cross product, I'm going to have 27 parentheses x plus 11 equals 18 parentheses 3 x minus 9. Remember to distribute to both, and then you can solve for x. X is going to equal 17. All right, let me know if you have any questions.